Hello, geometry students. Welcome to section 1-4, pairs of angles. This is Missy McCarthy at Okemos High School. You guys learned all about angles in section 1-3, and so now we're going to look at different pairs of angles and what they may have in common. Our first two pairs of angles are called adjacent angles and a linear pair. Adjacent angles are two angles in the same plane with a common vertex and a common side, but no common interior endpoints. So if we look here at this picture, we have a common vertex here for angles 1 and 2. We have a common side here for angles 1 and 2. And you can see that angle 1 is completely separated from angle 2. They don't share any interior points, so that makes them a pair of adjacent angles. A linear pair is also a pair of adjacent angles. They have a common vertex and a common side. However, and no common interior points. However, the two sides that they do not have in common form a linear pair. You can see this side here and this side here form a straight line, and that makes them a linear pair because the two sides are opposite rays. So let's see if we can identify whether or not some angles are adjacent and form a linear pair, or not adjacent at all. If we look here at angle AEB and angle BED, they have a common vertex, which is E, a common side, EB, and EA and ED form a linear pair, or are opposite rays. So therefore they form a linear pair. So these are adjacent and a linear pair. If we look at angle AEB and angle BEC, I can see that they have a common vertex, they have a common side, but EA and EC, those rays are not opposite rays, so these guys are just adjacent. And if we look here at DEC and AEB, they don't share a common side. Ray ED and ray EA are opposite rays, but they don't share a common side, so they are not adjacent. So they can't be a linear pair because they have to be adjacent to be a linear pair. So you might want to pause the video here and try this example. If we look at angle 5 here, angle 6 here, that's that one there, and that one there, they share a common side. Common vertex is P. The common side is ray PU. So that would make them adjacent. They also have ray PT and ray PQ as opposite rays. So these are both adjacent and a linear pair. If we look at angle 7 here, which is the same as angle SPT, and angle SPU, I'm going to say those are not adjacent because they share common interior points. And if we look at angle 7 here and angle 8 here, they do not share a common side, so they are also not adjacent. Another set of angles is complementary and supplementary angles. These you are probably familiar with from your work with math in the past. Complementary angles are just angles who sum to 90, for example, A and B here. And supplementary angles are angles who sum to 180, for example, A and C here. So if we have angle F, which is 59 degrees, and we want to find its complement, we have to do 90 minus the measure of angle F. So we would do 90 minus 59 degrees, and we would end up, I believe, with 31 degrees. If we wanted the supplement of angle G, they didn't give us a measure for angle G. They gave us 7x plus 10. So the supplement would be 180 minus the measure of angle G, which would be 180 minus this 7x plus 10, and we actually end up with an expression. 180 minus 7x, if we distribute our minus sign, minus 10, so we end up with 170 minus 7x. And that is actually the supplement of angle G. Okay, here's another example that deals with complementary and supplementary angles. So let's read it first. An angle is 10 more than 3 times the measure of its complement. Find the measure of the complement. For this one, there's probably several ways you could do it. I like to identify the angle and the complement first and then set up an equation. So let's call my angle let's call it angle A. So that's my angle. And I'm going to call the complement angle B. And I know that angle A, the measure of angle A, plus the measure of angle B must be equal to 90 because they're complements. So now let's see what we know about these angles. An angle, so that's my angle A, is more than 3 times the measure of, it's 10 more degrees than 3 times the measure of its complement. So the thing I don't know is the complement, so I'm going to call that X. I know that angle A is 10 more than 3 times the measure of X, so angle A must be 3X plus 10. So this is 10 more than 3 times the complement, and this is the complement, and together those must be equal to 90. So I would get 4x plus 10 equals 90, 4x equals 80, or x is 20. So it says find the measure of the complement. Well, x is the complement. It is the measure of angle B, and so angle B, or the complement, is 20 degrees. Our last type of pairs of angles would be what we call vertical angles. So here in this drawing, angles 1 and 3 are vertical angles. Angles 1 and angle 3 are vertical angles. And so are angles 2 and 4. So vertical angles are angles that have the same vertex and whose sides form 2 straight lines. So you can see here angle 2 and 4 have the same vertex, and this side and that side of angles 2 and 4 form a straight line, and then this side and this side of angles 2 and 4 form a straight line. So that makes angle 2 and 4 vertical angles. The same for angles 1 and 3. So in this vertical angles example, it says name the pairs of vertical angles. So I could say, let's see, one pair of vertical angles would be angle JMH and angle KML. That's one pair. And another pair of vertical angles would be angles JMK, and that is paired with angle HML. So those are the pairs of vertical angles in this diagram.